Okay, testing audio. 1, 2, 3. Okay, that sounds good. I think we're ready to get started. So, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. Today, we are on compiler day, so we are going to kill some buffers. We're going to kill all the stuff we've been working on. That's all on the other project. Okay, no. Right button here. Some buffers. Unmodified, unmodified. Yes. Everything looks like it's more or less unmodified. Scratch buffer's fine. HPP. We really do open a lot of buffers throughout a week, don't we? Okay, we're down to 2 buffers. Yep, scratch and messages. Which means we're ready to get going. So, into our Billion Bay project. Look at our to-do list. We look at our journal. Where we left off. We were in the Tokenizer generator. And there is a certain amount of boilerplate that we have to write before the Tokenizer generator is any good. And that's what we did. Character reference and string reference. We do not want to copy strings around. So instead we're going to maintain the text buffer in its entirety for a number of reasons. And we're just going to carry on these references which point to the buffer and where in that buffer the character or the string live. We generated character and string references for all 3 of the encodings we support, ASCII, Latin 1, and UTF-8. If you want something fast, I recommend Latin 1. If you want something more expressive, UTF-8. ASCII is like in between, I guess. It will do a little minimal checking on the character to make sure it's normal, but it won't force anything. Which brings us to this week, where we are in September already. I don't know how we got here. Seems strange to me. Ooh. Okay. So, picking up what our plan is for the day. Okay, so context. Let's talk about what a context is. Oops. Context. So we are going to feed a text file into a tokenizer and then pass the results of that into a parser of some sort. And all of these things have a certain amount of bookkeeping and data they need, which is shared by other processes within the same tokenizing parsing pipeline. So we're going to create an object called the context, which just shuffles the shared data around. So, for example, we don't need to write it here. Error messages. When you tokenize, you want to put out character, this is an invalid character, or we expected this character, like an unterminated quote, maybe. Later on, we'll have more interesting error messages we'll want to put in there when we upgrade to a PDFA. We want warning messages. We want the text buffer to stay around because all of the things we're passing around are references to that text buffer. So the parser context is going to hold that. So let's see here. Why don't we just write these down? Context design. We want the text buffer. We want error messages. We want warning messages. Things like that. Hey, Dravest, how's it going? So basically, every stage of the parser is going to want this context. So we're going to generate something like that. One thing I've thought about is we might put an iterator in our text buffer, more for performance comparison rather than for any good reason, like we need it. So those are a couple tasks we can tackle today. Ooh. And depending on how those go, we're going to jump into the tokenizer itself. Start generating the tokenizer. Okay. Today, Dravest, I'm doing well. Feel pretty good about what we've got done so far this week. So, all in all, feeling pretty good. Whew. Finished one client's work today. Good. New potential client on Monday, so that's nice. So, how much of your client work is repeat customers? And is it new project or is it maintenance on old projects that you've already worked on? I know. Doing contract work, getting those repeat customers, repeat jobs, those are very valuable for your stability. So come out. What the? That must be from yesterday's lineup. Okay. Okay. They're shared or intermediate. So, for example, when we way down the road start multi-threading things, but the thread pool is going to be here inside of the context. Client work finished today was repeat work with one on Monday as a new project. Cool. It's also good to get some variety in your lineup. Awesome. Okay. Thread pools, etc. Pools. Okay. So we're going to generate a context. Why don't we start small? Let's get the iterator in the text buffer. Let's take a look here. Source VD, test parser. We don't expose much yet, and we don't want to expose a lot. So we have our text buffer. Our character reference. And we do forward declare. So the text buffer could get its own iterator. Okay. I have some old code for making an iterator that works similar to what we're going to want to do anyway. So let's go take a look at that. Compiler for, I want to say, they had it. And this would be in UTF-8. What did I call that? Buffer. Okay. We declared a friendly iterator. So we declare the iterator. It is a friend of buffer. We could put it inside the buffer. Inside our text buffer. Really, this is not that complicated. So let's look up in our source. We're in VB project writing, where we write our text buffer. This is where it needs to go. Okay, so we're going to go quote, new line, and there we go. Okay, so that's step one. UTF-8 buffer becomes text buff. Might as well short iterator. Iter. Since we're being terse today, I guess. UTF-8 character reference is now just a char ref. We have forward declared, so that should work okay. Okay, so in theory, we implement these things. Can this be a friend? I don't think I need a friend, do I? I'm not sure we need a friend. Comment if we need a friend, we'll come back later. Friend, what friend does is it lets another class have access to your private data. So this public stuff is the stuff you're supposed to touch. If I say I'm your friend, then the other class here will have access to this directly. I don't think we need to be friends. I don't want to get too friendly, right? search for semicolon \n, put in a brace. All these functions will need to get implemented. Hey, Pat, welcome back. How's it going? How is it going? The other thing we need is this. Compiler day. Yes. Doing the same thing as me. Tests. Yep. Basically, development, whether you're writing official tests or not, development's almost like 90% tests. That's what you're doing. So, yeah. I'm going to send you iteration 2 of the interpreter. Yes. I still have the other code base. I just restarted, give it a little more guidance. And it already isn't using std any. Oh, really? Wow. So that is good. Did you just limit it to just C? Yeah, I think that's a whole separate skill set, is how to tell AIs what to do so that they'll listen. I don't have the patience for it. I'm too curmudgeonly. Computers don't respond well to sarcasm. Okay. Ooh. Stubbed out. Yeah. I still the right test for everything, and I was doing a decent job at least. Still an idiot. Yep. It's using variants. Okay, okay. Yeah. Variants make people feel safer, but pretty good tagged union. It does the job more or less. Okay, so let's see. We're stubbing things out. We're going to UTF-8 buffer. UTF-8 buffer C. Okay. And we don't care about any of this. What we care about is begin, which is actually very simple to implement. Oops. And it's not a UTF-8 buffer. Iterator. It is now a text buff iterator. Okay, the end is a. Oh, that's why we made it. That's why we did it this way. Okay. That's why we had to make it friend. So let me explain. When you make an iterator, you have to tell the iterator where to begin, which is easy. Just do this. But then when we say we go into the end, we're going to create one, but then we need to jump it all the way to the end of the file. So we need access to that character. It needs to still point to the same text buffer, but it needs to be at the byte offset. Does that mean character also has to be a friend of text buffer? What did I do with that? Oops. ref. Did I make everything private? These should honestly almost always be just straight up. I did make all those pieces private. So we have a choice. We can either stay to end. Ooh. Chandler Bing, is this a C++ compiler? Well, this is a compiler written in C++. My flavor tends to be more C-based. The language is undefined yet. We're still building early tools. The stages of a compiler go Tokenizer, where you take your text block and you turn it into individual tokens, or Tokenizer, Lexer, Scanner, I've already called all of those. Then you take those tokens in order and you arrange them into a structure with meaning. And that first stage, the Tokenizer, really it's not that hard to write your own. You write a loop and you do some ifs and that's it. It's not that hard. But because I like this sort of thing, we're going to build our own PDFA-based regular expression tokenizer generator. So we will emit code, which then compiles to be a tokenizer. I think we can write something pretty fast, like execution-wise. It's going to take us a while since I only work on the compiler once a week. But that's the stage we're at. We are generating a tokenizer from code. So code that writes code that compiles to read other people's code. It's good times. So welcome to the chat. Monday through Thursday, we're working on a game with no engine, and also in C++. And on Fridays, it's Compilers Day. So if you're interested, just give a follow, or I have a Discord server that I use to send out notifications when I go live. If you have any questions, let me know. I just code and talk stream of consciousness until somebody throws something in the chat. So if you have questions, let me know. If you want to talk about something off topic, that's fine too at this point. My chat isn't so busy that I can't slow down once in a while and have a chat about something off topic. I watch some of these big streamers and they have thousands of people in the chat. And I don't know how it just streams past. I don't know how they catch anything. So I like the smaller chat so far. I figured it also takes years to scale up anyways, but yeah, so hopefully that gives you a bit of a Mr. Ed makes So that's a decent overview of what we're doing. The language we're probably going to build ourselves is going to be probably C-like. It'll be my own, more of a toy language, nothing like commercial. Just I have some ideas I want to play with. I want to keep stripping back the layers of computation until I'm down on the bare metal, which at the end of this compiler project, which may take years if I only work on it once a week, will be me emitting executables from scratch myself. No linker, just emitting raw binary executable code. So we'll see how that goes. That is so far down the road. We'll see how much energy I've got. we will probably do some intermediate steps. We might emit C code. We might emit some assembly, different levels of things as we strip back the layers. I see. Awesome. So are you doing C++ that looks more like C? Did I hear you right? Yeah. So a lot of the modernist C++ stuff I skip over, like fstream. Like I'll use fopen and fwrite and that kind of thing instead. Um, I abuse the casting system quite heavily, so I'm not above type punning. I manage my own memory. I don't use the shared pointers or the unique pointers or the weak pointers. I know what they do. I just I'm trying to keep it as simple as possible. If I want to downport it to C, it's literally just removing the class wrapper layer basically, and you know that's mostly what you would have to do. So yep, mostly it looks a lot more like C than it should. I do use classes. Yeah, I use a little encapsulation, but I could get rid of it pretty easy. I will occasionally use the C++ containers if it's the non-shipping side of the code. So the tokenizer generator isn't the part I care about speed and control the most. So I'll use the occasional vector or list in the right places. But this part that we're emitting right now, this will not use any of that. Every line will be generated by us. So just for funsies, it's more for education and because I think that the DFA types of problems are super fun. Yep. Yep. I don't use a lot of polymorphism these days, unless I feel the need. So, for example, on my GitHub somewhere, I've got a random number generator where there's the abstract RNG, which will generate 31 bits of random code, of random data, and then for that I have 5 or 6 different generation engines. So the Mercian twister, the GB flip, Isaac. I've got linear congruential. So each of those would inherit from that one. That's one place where it's like, okay, polymorphism makes sense. You can use whichever core to generate your 31 bits as you want. And then that feeds in downstream to the different uniform distribution, normal distribution, generating points in a circle, generating Perlin noise, those sorts of things. Those all come because you can use any backend basically. But I don't tend to use a lot of polymorphism these days. I obviously, if somebody's paying me, I do whatever they want. It's not that I don't understand it. I can do it. In fact, I've overdone it a lot in my career. So this is just me peeling back the layers, and maybe I should just go straight to C one of these days, but there's still some flaws with C. Cool. So yeah, what's your interest? Are you interested in building your own compiler? This is, like I said, this is probably not the right way to start right off the bat with a PDFA. You either start with Flex or Bison, or you write your own tokenizer, write your own parser. Isn't that hard? There's some easy papers to start with, but I'm having fun. So yeah, like I said, if you have questions, let me know. I'm just coding and talking. That's it. I'm not a streamer. I'm not a content creator. I'm just a programmer who happens to stream. So welcome aboard. Advanced. Let's just make a function. Let's just go straight to the end. Void to end. Because there's no reason not to. I don't like friends. Anytime I declare friends, it feels dirty. It's like I didn't think through the problem well enough, and I'm exposing things that I don't really want to. So let's see here, m_byte size equals 0, or byte count. Byte count equals 0. And our byte offset equals 0. The buffer does not go away. Validity does not go away. The value can be set. The character offset will be -1 because we didn't count the characters in the UTF-8 buffer. We don't know. UTF-8, you have to start at the beginning and you have to count the characters all the way through to the end to know how many characters you've got. Either of the other encodings we support, the character and the byte offset are the same thing, but a UTF-8 character is variable size. So while we support UTF-8 characters in our regular expressions, we do have to treat them a little bit more differently. So this goes to end. Let me just call update, I think. And we don't put 2 quotes in right there. So what update does is it tries to validate the character. Since this is UTF-8, it's the most complicated. Bit masking, etc., etc. The first thing it should do in the update function is say this is not false. This is not. Let's see. So very quickly, it should do that. It should say this is invalid because we're at the end of the buffer and we go to the end. So that should. I mean, I can just do this, right? Here's this thing, value, byte count 0 is valid. So why don't we just skip that whole update column to end. We just skip the column. Invalid equals true. Okay. So that's kind of what I'm leaning towards right now. And we generate this 3 different shapes. So here we have a value, we have a character offset, which will be 0. Byte count is doesn't matter because every character in this encoding is 1. Oh, we did one thing wrong here. It is buffer called _buffer dot size. To end. To end. There we go. That's basically it for this. What is this, Latin 1 or something? And this encoding, value, buffer size, invalid. Yeah, that's basically it. So, which brings us back to generate our text buffer. To end. But we do have to be friends. We can't skip the friendship step, which isn't that bad since we have forward declared text buffer, and this is internal to text buffer anyway. So okay, back over here. The iterator. Actually doesn't do anything. Cool. underscore char given our buffer. Easy. Underscore char given our other. I think this one actually doesn't do anything either. Let's see, the destructor does nothing. It is not an interesting destructor. Equals, yeah, it's actually is pretty straightforward mostly. We're going to copy the other guy's character if we are copying the other thing. Operator dereference, we just return the character. Easy. That's what we were interested in the first place. Plus plus. We don't have to do any of that. We can do char.advance because we wrote this function ourselves. Return contents of this. This iterator. So we don't need this iterator here. I'm writing it up now because later on, basically every combination I can think of would this affect the performance or would this affect the performance, we're going to generate a pound define for it. So for example, let me just mark this up. In this write text buffer, if you load a file, you have different options. So there's the system call for open you can use, or you can build it with the library call for open, or we can even let you use the modern fstream version if you want. But you can, we're generating all the code, and you can build it with different compile flags that compare the actual time. Now, maybe fstream is faster, but maybe it's only 2 milliseconds, but our whole parse time is 3 seconds. In which case it doesn't matter. Or maybe it is big enough that it actually matters. I don't know. That'll be part of the testing way down the road. So we're not comparing our performance right now, but we are generating it both ways when we have a choice and putting a pound define, and then we will do performance testing towards the end when we have a working system, when we're able to run real volumes of code through. Because until you have everything in, you kind of don't know where the performance hits are. So this one is you don't really know where the performance is, and people have really bad intuition for where your code is a problem. Count equals 0, count, oops, int. Number of times, count less than our number, plus plus, count. That's basically that one. Equivalency checking. Is this the same buffer and is it the same location? That seems like a reasonable check to me. But you can't just check the location because if we're comparing characters from different buffers, they will not be the same character. Alternatively, we could we could check the value of the character. Oh no, it said this is text buffer iterator. So we do care if they're the same buffer. Does the character expose the buffer? I don't remember. So I'll have to think about that for a second. Or look it up. That's basically the iterator. So one of our options is that we maintain our own position as we walk through the text buffer. One is we use this iterator. I've done a tiny bit of testing on my own way back, gosh, a year or two ago now. So I know what I think the answer is, but it doesn't mean that it's a significant amount of difference. I don't know if it's meaningful amounts if you're parsing a million-line project. Okay, so I do have to know what those expose, but it is probably time for a quick restroom break. And we'll finish writing out this iterator stuff. Okay, we are back. So I think nowadays we call it contents, and we actually return the actual offset. So we're just comparing the pointers there. Ooh. Mm-hmm. Oh, not charge. What do I expose here? Assignment equivalence. Where do I check equivalence here? It literally just checks the equals equals. Let's just make another function. This is easy. Bool. Same as const char ref and other. Same, not save. Is same. Return underscore buffer equals other dot underscore buffer. I'm 99% sure that the buffer is a pointer. Yeah, so it's a pointer comparison, so it's fast and easy. And m underscore byte offset equals other dot m underscore byte offset. There, easy. Set. This one doesn't have a byte offset, it has a char offset. Just a moment. Okay. Back to it. That's really the only major difference here. So this equal. Okay, I think that's it. So up here, when we're asking char is same as other. Okay, that's a nice simplification, I think. Because at this point, I don't want to know which kind of character it is, I think. Okay. Is that basically it? Shrink things down a little bit. I saw that we were doing this below, so you know the style question. Not super important, but actually I like have the visual there. Um, okay, I'm gonna indent everything else more. So we're gonna search for a quote 1, 2, 3, 4. Not that one. 2, 3, 2, 3, 4, 2, 3. Right, so you have to keep scrolling. Control L. That one. Okay, so the text buffer class contains this class. Okay. Read file thing. Text. Reference text. Different ways we want to interact with our text data. Mr. Red makes, why have so much source code in a source file rather than an external file? Yeah, I've thought of that. It's why don't I? Why haven't I? Later on, so these three files we're generating specifically won't change no matter what the user inputs, other than it chooses which version of the file for ASCII, Latin 1, or UTF-8. So these files we could do that with. These aren't the interesting files. The file that's most interesting, the rest of the files are much more interesting. Because it's not just a static file. So I guess here's two. Well, here's two reasons to keep these files in here. One is the code that generates these is the same as the code that generates the more dynamic file, the one that is actually configured by the user. So everything's in one place. Two, this code being embedded inside the executable means I don't have to distribute anything but the executable. And nobody can fiddle with configurable with these files outside of the executable. As a trade-off, one thing I'm willing to do is have these files in a text file in my project, but then have a piece of code that reads that and embeds it inside of this executable. That is something I'm willing to do. Similar to what I do on my game project. Yeah, later on we're going to get to where we are generating a lot of code depending on the user's configuration. And so it's a lot of if statements and switch statements. We'll get around to it inside of for loops, generating code. So this part's not the most interesting part. I can be persuaded to keep these files outside, but embed them inside of this using like a pipelining type of script. But ultimately, I want this code to live inside the executable. I don't want it to be external to the executable when we run it. You know what? Let's go to our to-do. Here's our to-do list. Tech debt. Static code files could be brought in on an asset pipeline. Yeah, that's not an unreasonable thing to do. In fact, we do this in our game development code. We have our images, our PNGs, we have our wave sound files, we have our shader code. Those all live inside of an asset folder, and then we have scripts that say, here's how you parse the PNG, here's the data I want out of it, and embed that by generating basically a whole new code file that the rest of the game itself at compile time then includes. So without involving me writing asset pipeline types of code, which again, I'm not opposed to. It's a task. I'll throw it on the list. In fact, we could steal some code to do that. Yeah, different ways to skin the same cat. This one is probably going to get unwieldy enough at some point that I decide the asset pipeline is the right way to move some of that concern. Where was I? However, asset pipeline embedded code isn't always smaller, more compact, or more interesting. It's just basically a copy of the same stuff. Okay. Yeah, we basically have to have 3 files, one for each of the encodings. Same with the string. The string has to embed 3 different versions. Yeah. Although it turns out, as far as string reference is concerned, it only cares about UTF-8 versus non-UTF-8. ASCII and Latin are close enough at this point that it doesn't matter. So, hope that answers your question. Yeah, extracting this string and in fact we could write something that would pretty quickly export what we've already inputted into files. Then we just have to write the asset embedding pipeline. Okay, so where was I? We were at the point of running compile, and in this case we're going to do a clean test. I remember what test does. Field as incomplete. We'll declare that. Yes, I did forward declare it. Return type is incomplete. This is a problem when you have forward and backward dependencies. So we have a character which references a text buffer. With the text buffer iterator, can only be declared after text buffer and the character reference. So it would have to go here. And that's if did it regenerate that file? Of course it did. So we're going to copy, load, paste, there we go. So we'll save our version, which has the iterator outside the text buffer and the character. We gotta go look at the make file to remember what the make command looks like. So we do not want to run our generator right now. We want to run Running a debug build. Generate test. Build test. Debug. Gen test. Make build test. And now we can run build test with a modified file. Let's see what we get. I forward declare it. Invalid use of incomplete type. That's annoying. I always hate this stuff. Is that why we didn't do an iterator before? Because the text buffer has no tag about text buffer iterator. Or declaring doesn't seem to help. And all of this goes away if we don't have an iterator. Real sheet. All right, let's just scrap that. I feel like it's going not where I want to go. VB project ready. So, forward declarations didn't accomplish anything. Good to know. Oh, come on. Let me just remove the iterator. Boom. And here. All right, we'll just keep it simple. Keep it simple. Don't overcomplicate things. I have a typo. There we go. Build test. Okay. For dot size. Yep, that's gonna be a problem. Project writing. To end. Okay. Invalid. Oh. Wait a second. Is valid. Okay, so that's gonna be a problem everywhere. Is valid equals is valid equals false. Is valid equals false. Okay. Hey, what's up? What's up? We are good here. We're doing compilers today. We're doing some Tokenizer generator stuff. We are outputting code from code, which will read your code. It's all getting very meta. We just abandoned implementing an iterator because if you generate everything in the same file, there are some issues that simple forward declaration don't fix for a compiler, so that's unfortunate. But we don't really need the iterator. It was just a comparison thing. I could, however, we can bring that code back long enough to snag it and put it somewhere. There we go. So text buff iter dot backup. In case we ever want it back. I had a professor in college. He said, "Don't be afraid to throw code away. Just don't throw it very far." Tokenizer generator. It sounds so meta. Yes, and one standard disclaimer: this is not necessarily the right way to start your own compiler. The writing your own tokenizer is actually not that hard. It's a for loop. Loop over your text, and depending on what you get in the character, you make decisions which state to go to. It's really not that hard. But I like the DFA, PDFA kind of world, so this is a fun project for me, not because it's necessarily the right way to do your own project. It is very meta. What is it to compile a new programming language? Yes, so like a C-style language, but of my own making, toy language. Maybe I won't ever release it. Maybe it'll get good enough to release it into something. I don't know. But I just want to play with ideas. I've got ideas that I want to play with in language design. Different looping constructs, branching constructs, different things I want to play with. So, my own language, we're just a long ways from that. We only work on this once a week on Fridays, so it takes a while. So yeah, strap in. Let's do some compiler stuff. I think this was also supposed to go to that same chunk. So that goes into, what did I call it? I called it text buff iter back file. Yeah. There we go. Okay, so this all runs back to the old to-do. Not to-do, journal. We're going to note this. Started down the iterator line. Code doesn't compile because of incomplete types. Even forward declarations don't help. Code snippet saved off to the side. If we want to revisit later. Abandoning for now. Okay, so context. What we use a context. This context is going to contain a few things in our text buffer. So go to VP project writing. Actually, let's do the project .header file. So we have writing all this different stuff. No, we just do it this way. Okay. So in the weekly project writing, we write out HPP and CPP. Which is hidden somewhere. Right? There we go. This one. So we're going to expose the text buffer. We're going to expose the context. We may remove this one eventually. The context is going to be very visible. So VB project writing. Actually, write the CPP file. Write context writer. Project writing. Okay. Coding information we don't care about. Don't think there's anything else we need to do. Okay. La 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 la. Okay. So class. I think this is another one of those very static files. We can get away with just doing this. Okay. Okay, so what do we need? We need a text buffer. We could do a few things. Just do it this way. Const text buffer pointer. So this one. Structure, which for now doesn't need to do much. We want to do what? Add error, I guess, is a thing we'll want to do eventually. And I don't really have a clear design here yet. We're gonna add a warning. That's the thing we want to do. So the text. Okay, so here's why we're doing this one. The error and warning will contain tokens which reference the text buffer. So these all living in the same world makes perfect sense. Const char errors. We'll come back to that in a minute. And warnings. Static const int max errors equals some number. I mean, if you have more than 1,000 errors, nobody's reading that crap. Error length. Sure. So we'll have some number of errors of length, whatever we decide. Okay. Then we want these to be variable arguments so we can add things to it as we go. Other things we will need will come in as we go. I think I have string standard int. We'll probably need standard IO. Need C. STR, I think that's what it's called. STD. IO. There are maybe just leave this like this. These two codes will be very similar, except they'll write to the different errors. We want to know. I don't want these columns. We're going to write to them all the time. Int number of errors, number of warnings. What else do we want? Error count. Count. So each stage will be given the context, right? So the tokenizer will get the context and say, here's your context, go forth and do things. Then this will be handed to the parser. The parser will take this context and go with it. Right now we just have error warning. We want to actually, we can either log the warnings and errors for them, or we can return the error or the warning itself. Well, let's just do log errors. We can always change our mind later. Log ones, same thing. We could. So one thing I'm considering is making a struct to hold our errors. Something we could do. Okay. So here's one thing I'm considering. We're just kind of designing on the fly here. So you have opinions, you can voice them, but struct message. We also need a enum class message type. Warning, error. We could have other message types, but these are the ones I care about the most. Any message would have a message type. Char array of error length, message length. And we do message length. Messages, max message count, and message length. Number of messages. Maybe we do something more like this. Because oftentimes, so if we look at the output of this thing, which isn't helpful right now, but it would output the error, the warning, the error, the warning interleaved, right? So it's not just saying, here's the errors, here's the warnings, one after another. It's saying, as I went through the file, here's the order I encountered them in. So you might get an error, and then 2 warnings for the same file. So maybe this is more normal. like the context is going to be passed from stage to stage. So I'm trying not to shoot myself in the foot thinking only tokenizer thoughts. So this way we can expand the message. For example, in the future we might have a token. We want to actually pass in the token. There's other information we might want. For example, we might want the line number the message was encountered on. We might want the token itself. We may want the abstract syntax tree node itself. So this might get to grow a bit as we go. We need a buffer. We need someplace to store errors. Message count. It's all of a sudden the most straightforward of these. Int result equals 0. Return result 4. Index equals 0, index less than number of errors, plus index. If messages at index dot message type message type error count the result. Return it in the end. Same thing with warnings. So, and we could generalize this more, because if we add other message types, so we could just say int message count with an overload. Which means the message type has to come out to be public. Say message count all of them, or we can go through and count a specific type. That feels a little better for me. That will grow nicely. Log. This is user facing. They should be able to reach this. So let's spell it out. This is not an internal thing. We should shorten circuit. So log all the messages. Oops. Then you should be able to log messages by type. Two different overloads. Add error, add warning. know what? Let's just add message. Must specify the type, which means this one goes away. Okay. So you can kind of see where we're going here. Log the messages. Index equals 0, index is less than, oops. Image for number of messages plus index. Okay. So we're gonna do something like f print f. So if our message at our index message type equals message type error, or a warning. They both are different. STD error messages index dot, what do I call it? Message. Standard out. Message. Okay, we do this. We go quote modulus s new line quote, and I think that needs a double. Like that. Equals std error. Oh, we can go full ternary here, right? If it's an error, std error, otherwise std out. Fprint out. I don't know. We'll look at it. This would be somewhat similar, except if message type equals this message type, Okay, so what we have here is we get the total number of messages, we get message count by type. We can log all the messages, or we can log only the ones that meet our type. We can actually make this even easier on ourselves. File star out equals message type. Then blaze through the list. If the types are equal, I feel like this needs another curly brace. There we go. So these curly braces as well. Okay. Then lastly, add message. Message of message type. Oh, we don't need to find something. Let's just keep it simple. M for messages at current number of messages dot message type equals message type. Here's where we need to do all of the string formatting. So we need int count equals vs n printf, if I remember right. Let's see here. vsn printf. Yes. We're going to have it a null pointer buffer. We're going to say don't write any actual bytes. Here's your format string. And I need a VA list, so that's where stdarg comes in. Then we start the list. After the format argument. args1, args2, args1, args1. VA copy. Do I remember what VA is? VA copy destination and source. So args2 gets a copy of args1. Okay. VA end, I think it's called. So we're done with args1. We've cranked all the way through them once. Again, so what this function does is it does a variable arguments string n byte print formatted. That's what all those letters mean. So it's going to try to write to this buffer the number of bytes we said. So that's the F, the S string. The N is the number of bytes. This formatting, formatted string, and V prefix means we are passing in the args list ourselves as opposed to this dot dot dot. So this dot 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 is handled here, VA lists start and end. It's how we walk through these. We don't walk through them. It's complicated. Doesn't matter. So this, when you do this, when you say don't write any bytes, it will report how many bytes it would have read. So now we know how big our message has to be. If count is less than our, what was it called? Message length. Then we can proceed with an actual write. PSN printf of messages at our index. We're going to have to write all of the letters we told it to. +1. I think this adds the 0 itself. PSN printf. I think it puts the 0. The generated string has a length of at most n-1, leaving space for the additional terminating number. So I do need to check to make sure that the is count +1 is we have enough room. Count, format, and args2, which we have not gone over. So we made two lists. We said start with args1 after format. So this ... is put into args1 basically. Then we copied args1 into args2. So we have two copies of our list. When we hand it to this thing, args1, it cranked through them all, and this args1 is no longer useful to us. So we can end it. Say we're done with this one. But now that we have this count, we can go through this args2 list, which was a copy before args1 got cranked all the way through. Else we should log an error. Printf. We might write some convenience functions for error writing to the right things, all sorts of stuff. I don't know. There's a lot of ways this can go. Right now we're just dubbing things in. We'll see if it compiles as we build things. We'll clean it up, make it better. I feel like this needs a second. I never remembered how many backslashes I need. Error. There we go. Add message. Message was too long. We don't need to get into details yet. Like I said, we can add bells and whistles and improvements later. Then we VA end args2 to say we are not using this anymore. Okay, so we have add message log count. Okay, the constructor, so the destructor so far doesn't need to do anything because everything we have here is a buffer which we don't own. Do we want ownership of it? That's actually an interesting idea. That is an interesting idea. I'm going to say no, we're not taking ownership right now. I think in the future, what we're going to do is we're going to have some delegate methods around You know what? I kind of don't want the text buffer used outside of context. So I'm leaning right now towards context just having its own buffer that it owns and not passing it around at all, which means this goes away. This doesn't need much. Blah, blah, blah. Oops. But what we do care about is m underscore num messages is 0 when we initialize. The buffer we have messages. Yeah, that's it. That's all we need to do in the constructor now. The destructor, the buffer cleans itself up. All of our messages goes away. Yeah. So this isn't that bad, actually. So what we do want then is text buffer has a thing called read file. And reference text and copy text. And clear. We just want to delegate those methods to the context. I think that's it. I think that's what we want to do. Read file. So I can see this being used several different ways. Ooh, where's the copy text one? Okay. So what I envision is most of the time you're going to use this inside of a world where you're going to say, here, read this file and then go. That's probably the most common use. However, if I own a program and I want a little tokenizer in it, I might say, look, I've already got this text that I've read from user input somewhere, right? Maybe I got it from a text box somewhere. Here's what I want you to call it, right? So there's no file name. It's just, this is called user input A. Maybe it was like, mini program A. Here's the actual text from that I'm handing you, but I still own it. So reference it, but do not delete it yourself. When I tell it to copy text, it's, again, here's the label for what this is called. I'm handing you this text. I want you to make a full copy and own the life cycle of this text yourself. So this is temporary text that goes away at uncontrollable times. So it's up to the user to get the text into the context the right way. So I think we're just going to delegate these through. I think that's what we're going to do. And clear. I think clear was the other one. So context has nothing in the constructor. It's dead simple now. Oh, move to line. There we go. So setting text actually happens like this. And all it has to do is m underscore buffer dot read file, file name, then we're done. Easy. I'm just going to pass it straight through. Reference text, buffer label, text, size, pass it through. Savage Lord Severus. Hello, hello, welcome back. How are you doing? Good to see you back. Right, so the context. Oh, and then I guess we should do clear. We should implement clear real quick. Which is basically underscore number of messages equals 0 line quote. There we go. Doing good. Good. Glad to see you back. What's been happening? Contents and size. Do I want the text buffer? What do I want access to at this point? These are good questions. Finished that contract. Still no more work. Oh, that's too bad. I'm with you, man. I'm with you. I've not been finding a job lately. Working on a Twitch bot for something to do. Okay. What's it supposed to do? Is it scraping or is it generating? Or both, input and output at the same time? So like report baseball scores or something? I don't even know what people use bots for. I don't know. Honestly doesn't do anything. Which sometimes is nice. So we have number of messages. Ooh, let's move file handling up. Message count, logging, adding messages, privately. Oh, add message. There's a little bit more here we need to do. I forgot the bookkeeping. Oops. We need to do m underscore no messages. It's bigger. Here. If m underscore number messages is greater than or equal to max message count, that's going to be a problem. Too many messages. Let's see here. It was originally to play Pokemon community game, but I turned that off and made it more like a streamer toolbot. Okay. We'll respond to certain messages, mostly commands. Its main, most useful function is currency conversion. Have some common ones with their own commands. Okay. USD, $500. My chat is rate limiting you? Really? Okay, I'll try it. I have connected none of my banking information, so it shouldn't. Hey! There it is. £379, Aussie dollars, Euro dollars, rubles. Nice. 2 messages, really quick. Yeah, yeah. I see, I see. Well, that's kind of cool, kind of cool. So what does it take to write a Twitch bot? Is that like Python or they have an API? You got to upload it somewhere? You can also target specific currency codes like, okay, Japanese. Cool, cool. Well, since I'm not making any money, that's not the most useful script for me right now, but it's still kind of cool. Pound convert. I mean, why not? We can try that. Boom. 1,000 is 49. Wow, China's doing great. Turning Python just off your PC for now. Eventually, I could upload it somewhere and have it run on the server. Cool. I've seen some people do some things with chatbots in Twitch, but I haven't got around to it. I still don't think of myself as a content creator or streamer, so like all of those fancy bells and whistles aren't on my list. Japanese yen and Chinese yuan. Oh, right, right. Still, pretty cool, pretty cool. And it's a good skill, good thing to have, right? One more tool in the toolbox. Okay, so what we're gonna do is we're gonna just compile this and see where we broke it. A few places. fprintf out is missing a match. Which probably happens. Well, we should look at what line it's on. It's in log messages, which is the one we just fixed. Okay. So that's going to be a problem, that whole thing. You can do commands like Christmas, Halloween, and Easter to find out how long until those. Okay, let's try a bang. Yeah, sure. Halloween. That's when I get a 7 weeks, 5 days, 1 hour. Nice. Nice. Okay. Is it an open API or do you have to get like developer status or something? Or request? Oops. That's silly of me. Forgot to set my colon. I haven't even looked at Twitch bot programming. Invalid types. Const char. Ready clear. I type stupidly. Yeah, char. That's very cute of me. Messages, new line here and there. So that's for me. That's how long until Halloween in the UK. Oh, so let's see how. Oh, you don't support US? Come on, man. Play with your IA time zone. Okay, so let's go back to the Halloween one. In America / I guess Seattle's probably close enough. There we go. That's probably not right. Okay, well, we can do one more. Okay, let's do Los Angeles. 9 hours, yeah. So it picked up LA, it did not pick up Seattle. It knows LA. I was just trying to think of a nearby big city. But LA is what they usually go for the time zone. Yeah. Yeah, I think I'm 8 hours from UK. Right. Cool. Pretty fancy. Pretty fancy. I changed m_messages. Message count, m_messages at index. I should be able to get at the message type. That doesn't make me very happy. STD error. Oh, there's 3 R's. That's very cute. And of course, we copy pasted that everywhere. Ooh, Bing commands. All right. Okay. Random word. Trinely. I don't even know what that is. A threefold manner or measure. Okay. I can see that. Oh, I can pound define too. Okay. Well, let's do a new word since I already looked it up the hard way. Let's do a random word. And then define napery. That's okay. It's all. It's funny. Yes, I. Very nice. Very nice. Okay, I believe you. I'm gonna try one more time. We're gonna try this one more time. Random word. Unathletically. Okay, well, I already know what that is, but we can define it anyways. It's going to have a photo of all of us. Oh, definition not found. Wow. Yikes. Okay, let's define hypotenuse. Maybe it's just something I can spell. Eat. Oh, you probably brought it down already. Okay, well. Problem with public demos, right? Okay, this one I know. ESN printf. ESN printf. Dot message. Should bring me down to one error. And underscore messages. Const. Why is it const? Why is this const? I don't want this to be const. Message of this. It works with eats, but not eat, huh? They've changed the API. Oh, yeah. Good old documentation. That's not even the right command. I kind of wish Twitch had like a back UDC Urban Dictionary for less family-friendly ones. Pop culture stuff. Hey, there we go. There's not much of a definition. Eats, food, especially snacks. Yeah. Okay. Yeah, I know Urban Dictionary. I've never heard of the word, what was it called? The wordnik. Yes. I've not used that one before. Okay, so here's my favorite word of all time. Let's see here. I'm gonna have to have Google correct my spelling, so let me type this out. How close was I? Oh, I didn't have it. I was close, actually. That's actually way closer than I thought it would be. Okay, my favorite word. Boom. There you go. Hypopotomonstrous esquipedaliophobia. And I like this word because it has its own built-in irony. If you have it, you cannot be diagnosed with it. At least not to your own benefit. Yes. So if you have hypopotomonstrous esquipedaliophobia, then how do you get diagnosed? They can't tell you what the problem is. We know what your problem is, but we can't say it. I think it's funny. They could have picked something a little shorter for that one. Maybe logophobia. Anyways, just a small tidbit. I always find that sort of thing amusing. Why does dyslexia have an X and a Y in it? Yeah, there's no way that's going to get messed up, right? Yeah. You heard about the, let's see here. Hold on, I have to think about it. I'm going to mess up, not the punchline, I'm going to mess the setup up. Did you hear about the agnostic, dyslexic, gosh, anatidiophobia? Which one is that one? Fear of, oh, it's a hypothetical phobia. No, that is oddly specific. Oddly specific phobia there. Yeah, I don't know about that one. Okay, so let's see here. What did the it's agnostic, dyslexic, insomniac. There we go. Why was the agnostic, dyslexic, insomniac so tired at work the next day? He stayed up all night wondering if there really was a dog. Ah. We come here for the worst jokes. But we've got some good words. I have a whole text document full of words that I like, whether it's like just the way they roll off the tongue or the I should use this word more often. Okay, yeah, dyslexic man walks into a bra, probably gets sued immediately for inappropriate touching, right? Oh. So a man walks into a bar. He walks up to the bartender and says, "Bartender, I just heard the funniest American football joke. Do you want to hear it?" And the bartender leans over the bar and he says, "Look here. I played high school football. I was a running back. I weighed 215 pounds. See that guy over there? He played college football, and he was a defensive lineman, and he weighs 250 pounds. You see that guy over there? He played professional football, and he was the lead tackle in his whole league. Now, are you sure you want to be telling that joke in this bar?" And the guy says, "Oh, yeah, never mind. I don't want to have to explain it 3 times." You've heard that as a blonde joke? Yeah. Yeah. The blondes get a. I mean, I have plenty of blonde jokes too. We seem to rotate between like the Polish, the blondes, and things like that. With a blonde weightlifter, a blonde police officer, a blonde MMA fighter. Yep, yep. Poor football players. Yes, I feel so bad for them earning millions. So bad. It's like making fun of lawyers. They're fair game. Lawyers are always fair game. Oh, it's constant because it's in message count. Type for array subscript. How is m_score messages not subscriptable? We do it all over the place. Let's do a full clean then, just because we can. What was the one dude's name? What was that one dude's name? General Booty. That's his real name on his birth certificate. Ouch. His dad just happened to have the surname Booty and was a fan of the military. Yeah, yeah. So let's see. Have you ever read Catch-22? There's a character in there who's when he was born, his dad's last name was Major, and so his dad writes on the birth certificate Major Major Major, but then he tells his wife that like he named him Charles or something. I don't remember. Then he grows up and he finally gets to be an adult and he tries to sign some paperwork like that's not your name. That's not what your legal name is. So his name is Major Major Major, and he gets into the military because he was drafted. And then at some point, everybody above him dies, and he becomes Major 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 because he was promoted to that position. So he had an office policy. You can only see him when he's not in his office, and you can only see him in his office. So till Milo Minderbender tracked him down, caught him escaping out the window. Interesting book. I still don't think any of that's as funny though as the scientific research vessel, the big old Arctic explorer boat that they put up a poll online to name it, and the one that won was Bodie McBoatface. Whereupon they thanked everyone for participating and named it something completely different. So Bodie McBoatface was always a classic. It showed up in lots of references. Anyway, sorry. Sidetracked. Too many jokes. People never learn. Don't. I know. You would think after like the Mountain Dew naming their next flavor disaster, like you just don't ask people. to name things for you. It's a terrible idea. Absolutely terrible. The internet is full of people like, well, worse than us, frankly. All right, I need to read this so I understand the message. Int message count given a message type. Actually, let's just go to the message in context. Here, we do the same exact thing. This line right here. These are the same. We declared messages as an array. So why can't I subscript it? Microsoft made an AI one time and made it learn from Twitter after 24 hours is racist and supporting Hitler. If I remember, it was a bit of a had a filthy mouth as well. What's that called? Tourette's. Yeah, it sounded like it had Tourette's. Microsoft Tay. Okay, yeah. I've heard of it. I didn't look up the details. Um, yeah, Microsoft has a history of trying things poorly. And why would you pick Twitter? Oh my gosh. Well, even before that though, like you remember when the gosh, when was it? The 90s? There was the Furby, right? You get those little furry critters, and people would sit there and teach them to swear, and then they'd set them in front of each other, and then they would teach each other new swear words. That was before machine learning even got very good. So my suspicion is if I comment out this line, it's going to fail on the next instance of this. No, just because it's failing here and not here just means it hasn't gotten here. But why it doesn't understand that messages oh, well, we were very clever there too. We might as well clean that up while we're here. Project writing. Message type. New line. Line. Down here. I don't think this should be so hard. This is an array. Messages, array, int index. We've done this before. I told you this is an array right here. Right here. I do not want to have to dynamically allocate this. This is stupid. Which happens to contain a message. A message type. What is this error even doing? Yes, Microsoft. I guess people just have too much faith in humanity. It's like I tell my kids, like, look around you. What's the average intelligence? Now realize that half of the people in the world are stupider than that. So 2. Oh. 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 For loop is stupid. That's not the right error message. That's not the error message we should have got at all. This semicolon means that this if is using index, which wasn't actually declared. It was outside the scope of this for loop. Jeez, that may be one of the worst error messages I've had in a while. Yeah, sure, we're overwriting it anyways. It doesn't matter. Oh, jeez. I say that all the time. There's a line in the modern version of Sherlock I like. I forget exactly. It's something like that's because you're an idiot. No, no, don't get offended. Most people are. Which Sherlock was that? Was that Cumberbatch or Robert Downey Jr.? That sounds like one of the Cumberbatch kinds of lines. Yep. Actually, I think most people are the Benadryl Cabbage Patch one. Yeah, yeah. I like the first season of it. I think somewhere in the second season it lost me. When was it? About after the Hound of the Baskervilles. That one was the last one I liked. I think. I don't know. They were pretty good. Okay, so we're outputting a context, which is of moderate use. We lastly need const text buffer pointer so we can use that in other places. Because that was an important piece for other things to use. Study in Pink. Yeah, that sounds about right. It's been a while since I watched it, so I can't remember exactly. Oh, address. Address of. Obviously. The whole point of that text buffer is that it's basically constant throughout its whole life. It reads a file, and then nothing ever modifies it. Because later on, like when we're doing proper error messages, we want to know what line the message is on, and oftentimes a good compiler will output the line of text with a mark saying, here's the token we were looking at. So being able to access that whole line later is good. So we're just going to keep the whole buffer around. We're not going to copy any strings ever anywhere until it's time to print out messages. So like this add message, it doesn't copy, but at that point, you're telling me something's wrong, so I don't care about the overhead of copying a string. But as far as normal processing, outside of errors and warnings, we want it to be fast. So as fast as we can. Okay, well, it's there. We could test it. Maybe it's time for a snack run. Quick snack run. Then we'll do some testing. Wow, I cannot hit exclamation. There we go. Okay. I can only chew gum for so long these days. I'm trying to lose some weight, so I can't just eat junk food like I normally would. I've already done that for the last, 15 years. Time to fix it. So we have all that done. So I guess we really just need to test it then. Test. I'm gonna do that. We're trying to delete everything here. That was all related to testing the generated character reference, string reference, and the text buffer. So if those are all working, all we really need are strings for different test cases. And we are going to grab a VB test parser context. Context dot, I guess we'll copy text, which we will call test. And I do not remember what we generated this with. So if we go load up our, what was it called? A test.vb project. So we're in Latin 1. So it will handle this string just fine. Actually, let's do this. Const char star Latin 1 ETF 8. And const char star ASCII. There we go. Now we can switch between tests much faster. Const char star test or text equals. We are doing Latin 1 right now. Oh, wait, hold on. Yeah, that's fine. That's fine. Latin 1. Actually, we can just reference it. You don't have to copy it. This will live throughout the duration of the main function, so we have access to it. I think what do we want to do? Maybe like context.add warning, add message. You can test parser context message type warning. Obviously, if we were working, we're not working in this area directly. Later, this is all coming out. So I was testing it. Looks a little verbose, but it should be fine. This is some number of bytes, and this will be context dot buffer point to side. That's a pretty reasonable test. Add error or add message error. Why this folly? Messages. Context dot, what was it called? Message count? Errors. warnings. All messages error messages, warning messages, context.log messages, error messages, and warning messages. Anything else we want to do? I guess we could clear. That would be context.clear. And log note usually key bytes remain. Oh, it's bytes. I think that seems like a decent coverage for this test. Oh, warnings is plural. If I spoke English, I would have remembered that. Okay, so here we run this, and we should get predictable output. So meta-x shell c dot slash source builds debug dd test parser.exe. Messages, there are two. There's one warning, one error, one warning. All messages. Why this folly? This is 18 of byte for the question mark is missing. So we need to add a +1 somewhere. Error messages, why this folly? Warning messages, this is 18 of byte. After the clear, messages and bytes are 0. So we're close. Very close. So we're off by 1. 18 bytes. Was it 18 bytes? This is the Latin one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, it's right about that. It did get the 18 bytes. So something in my message is wrong. Question mark and the S are missing. This is modulus d bytes. Oh. Okay, so let's go take a look at that. VV test parser add message. So that needs to be fixed. We start, we copy int count. Let's do a little bit of hack and slash. Let's hack and slash it here. Let's hack and slash it here. Let's see what we get here. That's there we go. I should have that one. Okay. Okay. Load it. Fix that. Okay. Now, if count, let's do int bytes equals 0, bytes equals thing. Note. I guess this thing doesn't have a log, does it? Let's go printf read modulus d out of modulus d bytes, or message was we read this many, or we wrote this many bytes. We expected this many bytes. This was, oops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21, 22, 23. So the 24th byte, I guess, needs to just be that much bigger. So let's go to the project writing. I guess when we actually write it, we write count plus 1 bytes. That doesn't make any sense. Maybe it does. No. Redo the whole thing. Test parser. Run it. Yeah, it's all there. Okay. All right, so we'll probably just call that a win for now. So, journal. Basic parser context created. Error warning messages and text buffer provided. tested in test.cpp. All right, status and text buffer.back. I don't want to commit that necessarily. So I guess we just add that to our git ignore. I'm surprised star.back isn't already in there. Generating parser. Because all of this stuff is going to have to get more complicated. For example, the text buffer needs to know where each line starts and stops. Just for example. Okay. And now, the tokenizer. So to be honest, this is this is 1,000 lines of basically basic code. We will have pointers. We're not doing that yet. Oh. Yeah, we should write those up as to-dos. Don't know if character reference. Should be clear when it runs out of. It's literally just a pointer to the buffer and some numbers. Okay. Now, oops. So the fact that this is 1,000 lines of code to generate the test parser about 500, keep about half of it. All right. Thinking what we need. It's a couple of helper functions. Right. includes. We're using C standard IO anyways. Okay. So in DB project, where we write the CPP, we write out our includes, we write namespace, a blank line, then we do a bunch of stuff. So what I'm thinking is, I'll write a little helper function here. EA list, there we are. EA list start end. Writer. Start, stop, end. BF print F, I think, is what I want. Yes. Standard out, just standard out. Args 1 equals args. So prefix the word error, etc., etc. Basically, these functions should be available to everybody. So if we go back to here, we have these to-do errors. Now we should be able to say log error. Could not find file. I don't know if that's not escaping. Okay, let's just copy those. Let's see here. Could not open file. The modulus d bytes. Expected modulus d bytes. Size and count. Okay. Okay. I think this is what we need. Greetings and happy hacking. Welcome. Thank you, tuned. Welcome, welcome. How are you doing? Um, okay, let's just try this out real quick. Good, good. We're good. We're good. We're hacking away on some compiler stuff, like pre-compiler stuff, like the tokenizer generator portion, which is not necessary, but it's the kind of thing I like to work on. So that seems to be working. The UV test parser. Those functions look usable. VA list, VA start. Print error. Format with args. Print a new line. Log warning. Okay. Okay. Now down here, we do this error stuff here. We're going to replace that with our new stuff, as we could here. Okay, so let's do that. V project writing. So yeah, generating code which generates code is always fun. So I'm going to do log error. Log error. STD error. This one is fine. Oh, is that true? No, we can make this work. If this is error, log error. Equals warning. Log warning. We should make this in a switch. How do you feel about a switch statement? So we can do this, which means it would be easier to expand in the future. There we go. So that might be a little bit better. This one, we don't need to look up this at all. There we go. So if our message type is error, we use log error. Otherwise, we use log warning. We can, of course, make this more comprehensive here in a bit if we need to, but we just use that log function over and over again. Should be good. Okay. Once more into the breach. Warning showed up. Warning error. That's very cute. All messages. So this one should be the error. This one should be the warning. So error messages came in, right? All messages. We'll do all messages. For some reason, we did something weird. If the message is an error, we log error. Otherwise, we log a warning. Pretty sure that looks okay. Full clean. Okay. All messages. Warning prefix, then the error prefix. It's not what I told it to do, I think. If we log an error, we get our args from format. We printf to std error. Warning does the exact same thing. Therefore, I'll go through here. Oh. Wow, okay. Okay. Flush std error. Okay. Now, yes, all messages. We get a warning that's 18 bytes. Error, why this folly? Yes, much better. You should always flush. Remember to flush, gentlemen. Your friends and family will love you more. You'll be successful, get a better haircut, and your computer will love you more. Or at least the output from your console will. Okay, so we're going to commit update to consolidate some minimal logging in the parser namespace. We could put that inside the context itself, but I don't think I need to. I think this is okay. Okay, so over to the journal. The tokenizer. Useful functions for logging internal to the parser. Okay. Okay. So over to the project. Void write tokenizer. This is where things actually get interesting. PV project write. Honestly, everything below here is not interesting. Let's stub out our class. There's a whole bunch of stuff that needs to go at the top one. Let's take a look at an old one I did. We're going to make it different, but back in the day when I was fooling around with this stuff, no, there. Parse Philly tokenizer. Philly tokenizer header. So you see, I was passing around messages instead of keeping that in a context. We had this buffer thing, which again we should keep in our context. Token class. I may just get rid of this altogether. I think I have a way to do it. We'll get to all that. That's why we're not just copying and pasting the code that generates this. Tokenize. There's a bunch of helper functions like clear. We did make an iterator. We'll probably get rid of the iterator. So we're not at the end. It simplifies a bit until we add blocks and contexts back in. Parse root. Okay. Clear. Some reporting stuff. Are we at the end? Where are we currently? So here's kind of the thing. We have where we're currently pointing. We have the ability to consume this character as part of the token and move forward. We want to start a new token, so when we close an old token, we're like, hey, we've got an identifier, or we have an integer. As soon as we finish it, we should start a new token. We need to mark when things are new lines, and that will be when we start updating text buffer to keep track of line numbers. Oh, I'm out of snack. Okay. We're going to skip over block for now and context. Don't worry about those. Then, when we accept a token, if it's like comments or white spaces, we don't have to do anything. But here we keep the token, here we keep the token, this sort of thing. We're going to skip that. Parse root. At the very start, we start a token, we say, here at character 0, C is the start of our token, or start of our whole thing. While we're not at the end, cranking through forward, we're going to get the current character and go places. So this is kind of the beginning of it. So let's go output something. Right now it doesn't have to be great. Class Tokenizer. There are large chunks of this that are fairly static, so I don't know how individual lines I want to get into this. We want public, we want private, opposed to read after that. We close out the class. Oh. Nope, it just goes this way. Okay. Write the tokenizer. Let's just see where we're at here in VB project. Write CPP. This one. Write tokenizer. So the main thing, I'm going to create a tokenizer inside of context. And at some point, the tokenizer needs to initialize with our context. All right, back to the gum. Random snacks. Okay. So I guess the question is, what do I want the user to see? What should they type to get it to start? If I was a user, let's see, let's go to, oops, test.cp. Or let's go to scratch buffer. I want to say pound include vb test parser.hpp. Then somewhere in my code, I want to say vb test parser parse file path to file.q, whatever your language is, I don't care. And I want to get the AST out of it. So, okay, what's some other ways I might want to do this? I might want to say parse text like you're doing the expression evaluator. A plus B equals C, right? Doing an expression evaluator, we might just be parsing snippets of text to get off the website or out of a UI, or off of a console. So this doesn't really have the copy versus reference about the ownership of that text. You might be able to hand me the text, and I don't even have to copy it or delete it when I'm done, because I know you've owned it. So that might be a thing we care about later, but maybe not. Okay. So that's one thing. So that's for going all the way to abstract syntax tree. However, people may want to write their own thing. Let's go VB text parser, tokenize file. And tokenize text. Now there are two options here, I think. Because someone else might want to write their own parser. Just because we provide an LELR parser generator does not mean that that's what anybody wants to use. Maybe they just want to skip the tokenizer part and do their own parser on top of our tokenizer. So two options. Number one is we blast through the text and keep a container of tokens. I suspect that there is something else that will be better. Just lazy evaluate tokens as they request next. Now, there are two arguments. One is, if we blast through the text all in one shot, we get good localization of code and of data, because we're walking through this file sequentially, So a lot of that text is going to be loaded into the cache very nicely for the next character, for the next character, for the next character, through to the end of the file. So code and data local cohesion is the reason to do this one. This one is we never need to store a token. So if you say, tell me the next token, I can hand you the current token. I don't have to keep a backlog of any of them. So that reduces our storage, our copy. We don't have a list. Either way, we do something like while test parser as token test parser next token. It might look something like that. See, this one hides a ton more information. This one, I actually think I can do it this way. If I want to allow the lazy evaluation, I need to actually have the tokenizer available. If I do this, it looks a little different. What do I want it to look like? Design time. This isn't quite the whole story. No, I don't. Context. Then you'd ask the context for the AST. Tokenize and parse in a single operation. Also allows nice red pooling, pool usage. So we could say you parse file, and it'll have a thread pool. Let me think. We're just gonna play with a tokenizer. Let's not get too far ahead of ourselves. So our tokenizer is going to get a context. Constructor destructor. So if we set up a thread pool, each thread will have its own tokenizer, its own context. Already did a push, so that should be fine. Set context. This is probably the right building block. This context needs to be passed around. So yeah. Context star context. We want all of this to become code thread safe in the future. Don't need to worry about that yet. But we do want to keep in mind that the tokenizer needs to exist. Like it can't just be a static class or just a namespace. It has to hold its state. Going to context. Okay, yes. We want to generate this two different ways. One is asphalt pool has token. Token next token. Found define lazy tokenizer ifdef. Hash and if thing. Or we can say ifdef batch tokenizer. And we want to do something like this. If we're doing a batch tokenizer, we want to say void tokenize. Basically, do everything. Then I need to ask for the tokens. For now, now what? Reference to a token array. Whatever that means. Maybe it's a type def of something like an std vector, or maybe it's our own custom data type. I have it. We need a function which initializes our tokenizer. We need a char rev current. You know where the current thing is. How do we do the other one? Let's see here. Early tokenizer. Character byte line buffer iterator. At the end. A char reference of m underscore token start. token starts somewhere, then goes to the current character. So we need a function for push. We want to do void starts new token. What that's gonna do, let's see here. Current. Let's see here. Charref. Okay, charref, I can't take a null, I can set buffer. Oh, I cannot. We should do that. That is the thing we should do. Set buffer const text buff. Okay, so now set buffer is an option. Set buffer context. Start new token. So we set our context, we say we need a line number. Okay, this one finally is getting long enough. Much for line 0. I guess. underscore start. Oops, underscore line equals 0. Start new token. When I say start new token, we need to keep track of two things. We know when the token starts. Token start line. Token start character in the line. So start new token. Starting with one line, underscore current. Starting character in line equals current line. So we need to keep track of char in line. Which character in the line are we on? So we start over, we start off with the 0th character in our line. Start a new token. The token starts on the line. Current line. Underscore char in line. Whichever character we are in the line. That's mostly it for token. Oh, we also need token start. Equals underscore current character. Okay, so we're going to mark the current character as our starting token character. We're going to record what line we're on. We're going to record what character we are in that line. Good. We need to describe how we handle a new line. It's mostly these two things. A line will increment. Our character in line goes back to 0. So when I say, hey, we found a new line, the token will get the right line information. Okay, right? Those are helper functions we will need. We set our context, we start a new token. Let's just see where we've probably got a bunch of typos. Oh, the bots are back. They keep telling me I have better viewers somewhere else, but I don't believe them. I think we've got the best viewers. But one shouldn't have to pay for viewers, really. That just seems silly. Okay, so we have a tokenizer. Says the context is null, the line is 0. Maybe we make the line -1. I don't know. When we set the context. Oh, interesting. File writer. Nope, not that one. Going four index. There we go. Okay. Our context, our current sets the buffer. Line is 0 character in our line is 0. Start a new token. Do we have a token? Can you tell me the next token? Otherwise, the batch token errors blast through everything, tokenize all of it. Or, and then I need a way to get the tokens out. Private. Context. You have a current character, you have the start of the token, the line of the character. Okay. So after batch tokenizer, PV project, writing. Blank after the batch tokenizer. Okay. What? Toke start. Char. That makes more sense. Token starting character, token starting line, token starting character in the line. Yes. New line does that. Okay. What else do we need? We need. Let's see if that's builds. I can swear we added one of these. Oh. Oh, okay, okay. I see what's going on here. Char ref set buffer. There we go. Set buffer buff. Right there. Not right there. Right here. Set buffer buff. Yeah, maybe part of me does want to start looking at moving these files out. I think there might be some good value there. Oh, cannot convert. I knew that. So movie project writing set buffer. Not context. It's context point to the buffer that it contains. There we go. So in testnet CPP, let's do this. this. We will no longer add artificial messages. Messages. Okay. Context reference text. Okay. Then out of VB test parser, we need the tokenizer. Tokenizer set context equal to address of context. That really all compile? Okay. Errors 0, warning messages 0. Perfect. Okay, we're getting there. Let's just go ahead and take a look at that file. Actually, maybe test parser. So what we've written so far. Oh, it's way down here at the bottom. The tokenizer right now is very small. Context buffer line, character in line, start a new token. I don't know what a token is yet. I haven't defined that. Or a token array. So that's coming. Context, current character, current line, current character in the line. So we had something in the other one called munch, which was in VB Billy tokenizer.c munch. Bookkeeping. Oops. This munch. You can see a lot of the same ideas are coming through, even though we didn't copy paste this stuff. The line, the character, we're in the line. Token rule ID, that would be a good one to keep track of. Okay, 4 o'clock. Quick restroom break. Keep going. are back. Now, new line, start token, money. Oops. So let's steal that real quick. Writing. We need a much. New line. Read. Because sometimes you'll look at a character and you will not advance. It's the first character of the next token. And sometimes you look at the last token that hit the character and it will be consumed in putting the current token. So that's why we have to distinguish between whether we're advancing or not advancing. So do that. Now, character count, we don't care about. Character offset in line is up to us to advance, which is char in line. We're not going to do that. We are going to top underscore current dot advance. That's basically it now. Since we're using this advance function instead of an iterator, this is actually much easier. Okay, so let's go see what our code quality looks like in our generated code. If it generates code, because I can write the letters in the right order. Speaking of dyslexia, although that was a while ago, I suppose maybe it's no longer secular. Okay, well, it seems to have done the thing. Which kind of means we need to define, okay, more and more I'm thinking this might be useful. Our code is growing a lot. And there are large chunks that are very static, so. So how do I want to proceed? I want I want to change this one. Wow. Return underscore current character dot invalid reason, I think is what it's called. Oh, let's see it. Done or spool done return. return it's not valid. That's not quite right. Return invalid reason equals char ref invalid reason end of buffer. We aren't done until we're at the end of the buffer. So that's actually not that bad. This one, next token, is actually the part we care about the most. We want to iterate through until we complete a token. And that is very different logic from this one. This one is more like how I built my prototype. So in Billy Tokenizer, wherever that was, here, parts root. Start parsing. We get a start token. Start the token. And we start here. Well, we're not at any at the end. This one, so if I accept the token, I'm trying to remember. Let's go back to this. So this is more like what we were talking about with the blast through the tokens all at once and save ourselves a list. In this prototype, we were saving it in a list of in a vector. I think it was constructing the token when all of the information was complete. Oh, the tokenizer. We need the token IDs from the tokenizer. Oh, we're not writing those out, are we? We should do that. Okay. That's the point. Our current parse root does this. We need to do this part though. Put in the token. What's in our token here? Do I even remember? Really token. This bad boy has a list of valid enum values for type. We can start a token with a UTF-8 with a string reference, a line number, a character, and line number, and the ID. So that all makes sense. I don't see any issue with that. This equivalency check. Give me the text. The line, character, ID. What's the index of the ID? What's the string of the ID? Yeah, this actually looks like another piece we can just straight copy. Ooh. Except for this part. This we have to generate for our own token. Literally everything else is copy paste on this thing. Hmm. Let's see here. Good writing. And test. Still runs. The test parser. See any major errors we need to worry about. Text buffer. This has been the same for a while, and we've cleaned this up before. Character reference, same. Or string reference. Context. So before context, we need a token. Does this all look right? Message types, reporting an error, 0 messages, nothing. Okay, so let's take a look at that real quick. Extra return there would be nice. Clear message count, buffer. More or less look this all over. Tokenizer class. Kind of looked at. Bunch. Okay. It builds and runs. Downloaded Emacs. I was looking for a tutorial when I found this. If you haven't already seen it, it's worth a watch after your stream. Heading out to pick up the kids. All right, have fun picking up your kids. I'll take a look at that. There's a lot of good funny Emacs memes out there. I cannot lie. Emacs Pinky is a thing. We may have to talk if you're actually going to try Emacs. I can save you some carpal tunnel. Yeah, thanks for dropping in. Appreciate it. Okay. We need a token. Sounds good. Yep. Yeah, have a good night too. Bye-bye. So, honestly, this item is moving higher up my list. A lot of this other stuff not really high impact. This could simplify my code quite a bit. Maybe. Oof, I don't know. All right. Okay, so in here we have to generate a token. That's the thing we have to do. Okay. Now, So all of this actually sounds reasonable. As a starting point. Therefore, okay. Right line. Now, anything that says UTF-8 needs to go away. String references are fine. So this one we need to specially generate. This one's a simple constructor. This is a simple destructor. Some part of me is starting to think that through that pipeline, asset pipeline idea. There's a piece of it. Like the ones where I'm dumping whole files, it's fine. It's actually dead easy, simple to implement. Etc. But the case of this, where I have a file, which is some things in the beginning, I'm going to generate something, then a whole bunch of other static stuff, then I'm going to generate a bunch of stuff here. String ref, line, character in line, ID. Yeah, all that looks okay. So this would go here. Just so we stay on the same page. Okay, here we just copy the string reference. We're not copying a string, we're copying the string reference. So that's an important distinction. The destructor shouldn't have to do anything, so that's fine. Equivalency test. That's actually dead easy. So in this case, we're not comparing token to token. What we're doing is we're comparing a token to an expected token ID because of the way that the grammar looks at the tokens. It either cares about the token ID or it cares about the text within it. But never anything more complicated than one of those two cases. Drevest, how's it going? I'm doing good. How are you doing? You're still up? My goodness. What is it like? It's really late there, isn't it? It's after midnight, right? Crazy sleeping habits, people. I can't say much. If I had my way, I'd definitely be sleeping way later at night than I do. I did overload all those, didn't I? That was very clever of me. Return my text equals other. Because I already have an overload for string reference comparing itself to a character array. That's very smart of me. I don't know if I need this. We're going to chuck it for now. Or there's two different ways we can do this. I don't actually want people interacting with a string reference. So maybe we just leave that alone for now. Let's just leave that alone for now. Int line is easy. Return image of line. Yes. Int. You can call it char in line here. Okay, ID index. Static cast to integer underscore ID. Easy. People want to look at things in different ways sometimes. Return. ID to string now. Of ID index. This thing should probably be private. Static const char, whatever. Oh, yeah. All of these lines. So, like I was saying, while I'm thinking that asset pipeline would be great, it'd be even cooler if I could define this whole file, but it would auto-segment it. So whatever we store in our asset thing, it would be like, oh wait, this is where I write some of it, so this is segment 0. You write some stuff, then you tell me when you're done, and I'll continue with segment 1. Then when I'm done with segment 1, you write some stuff, and then I'll write out segment 2. Or 1, 2, 3 instead of 0, 1, 2, whatever you want. So what would that even look like? So I basically have this file in here, except a line with ... is what segments it. Maybe? So that's the reason I haven't moved a lot of this stuff into an asset pipeline. Is oftentimes there's just like one little line at the end. It's like, all right, so we wrote out a bunch of stuff, then I generated some responsive code, and then this last line is just dangling there. So maybe if we did a dot dot dot, if a line contains, so if it contains literally nothing except for / dot dot dot, or some other more meaningful string. I don't know. Yep, still up. It's Friday. No, that's fair. 1:30. Good heavens. Since I have nothing planned for tomorrow, I can sleep in late. Nice, nice. What are you up so late working on? You still doing client work, or are you working on a private project, or watching a movie? I want to look at it. See here. If I do a Python-based text embedding, this becomes trivial. I can look for / dot dot, and that would be a piece of cake. If I do it in C, it's a little bit harder, but doable. I think that might be the answer. We might spend some good time on an asset pipeline next week. In the meantime, we're going to stumble forward on what we've got. I think so. Oops. That one needs to go here. Which leaves us with, we need to output this stuff. All the way down to here. Writer, right line. Of class. So basically, our asset pipeline to do this kind of segmentation, automatically figuring out chunk that. I've been doing and learning some VFX work in a software called Houdini. Heard of it? Oh, cool. Video editor. Nice, nice. I keep thinking I should do like more polished scripted YouTube videos or something. Like after after the game project is done, do some more educational polished videos, but I found that I just don't really care for video editing. Like, and maybe it's the tools. Like I'm using Blender for the few times I've tried to sequence video. Yeah, Houdini is. I've not actually tried it. And maybe that's my problem. Maybe that's why I don't like video editing. Not that Blender's that bad, actually. It's far enough between uses that I can't remember all the keyboard shortcuts that made it bearable the first time. If you know what I mean. Yeah. That's a pretty cool hobby, though. I approve of good hobbies. Everybody should have a good hobby. You have any like sample videos up anywhere, YouTube or any good VFX you've worked on? VV Project has a thing called like Tokenizer definition. And VB tokenizer, oops, definition should contain a list of token names which we do not expose, but which we could expose. Const thing reference token names. Easy. And VB project writing. A reference to that thing. Int index equals 0, index less than token names dot size, which I have always hated. I want length or count. Size means bytes. That's how I use it. I got bit enough times. Dini's not video. It's a for fluid, smoke, fire. Okay. Okay, so it's strictly VFX. There's no. Okay. Okay, still pretty cool. I've definitely not gotten that far into VFX. I have a nephew that is into some VFX stuff. Modeling explosions, fire, smoke, that sort of thing. I don't know that he makes a lot of money doing it, but he does make some, so, you know, kudos to him. If index equals token names dot size minus 1, we do one thing. Otherwise, we do something slightly different, but very much close. 1, 2, 3, 4. 1, 2, 3, 4 modulus S equals modulus D. That would be token names index and index. Whereas if it's not the last thing, we have to put a comma in. That basically takes care of that chunk. Actually, writer to blank. I'm just going to put the closing brace right there. That's a little bit more readable. Okay, so that's one. Basically, gonna have to do that again down here. Except instead, where's that Billy token? Yeah. 1, 2, 3, 4. 4. Yeah. Backslash quote. Backslash quote. Backslash quote. Backslash quote. that basically takes care of that chunk. So token should get generated, and see how close we came. Doing things in 3D. Yeah, I think I'm gonna do 2 or 3, or maybe 4 games in 2D before I switch to 3D. I want to see a lot of games in 3D, and then they use their 3D resources to do the 2D elements like the UI, and it's like, ooh, wow, that's some heavy lifting for a bit of light UI. So I want like the 2D all locked in, clean, straightened up, and then I'll dive into the 3D. There are some things you can do in 3D that you cannot do in 2D. True fact. True fact. Okay, so Tokenizer. Oh, haha. Project.cp. Right. Token. Okay, nice. Yes. Yeah, still, if you have any demo videos or anything. Oh. I did. That's shameful. Copy, paste, copy. Oh, yeah, integer types. Unit 32T. Unit 32T. Static const char star ID to string map equals things in class member not da da da. How does it look though? That looks about like I'd expect it, which is good. What is that? Abomination. Oh. Okay, otherwise things are looking just about ready now. Things I want exposed outside of in the real world. If you look at VB test parse here. I actually want the context declaration here. We do not want text buffers. Let's look at a project. Right, HPP. Okay, we don't want a text buffer here. We do want class context. Context. We want Tokenizer. These two we want people to look at. Right. Now, context, unfortunately, In public. We called it Billy token? Yuck. Yeah. Asset pipeline. I don't really want to go down that road right now. It's kind of getting to that point. See, we're just growing the code too fast. We need a text buffer, character reference, string reference, a token, a tokenizer, context. Yeah, this is getting too big. Yeah, next week, definitely doing asset pipeline work. Okay. Writer push message type. Writer error. Link. Writer top contacts. This is a header file. All we need are the declarations. Clear. Time for bed. It's early though. It's only 2 o'clock. Yes, have a good weekend. See you on Monday. Back to game development. Be having fun then too. Here. Get some relaxation in. stuff. There we go. We're doing buffer, then message count, then the other message. Versions of logging messages. Version of that. That's good. We were very efficient that one. Right, so to top. Then we go to link. Okay. Here. I want to do the struct definition first, actually. So we'll go right here, point to top. Here. Okay. Yes, yes. Writing code that writes code can take some strange turns. Struct. Okay, then a couple of things. Writer. Top. Top. We link. Work our way through this here. So. Okay, so that completely defines the context, which means the context that we're generating here does not need to be within a class at all. We can just do that. We just need to namespace everything. Put it this way. for our implementations. Whoa. These things will be defined or declared and defined in the same location. This goes away. That all goes away. Okay, and that's mostly it. So we're gonna search for, oops. Search for a quote. 1, 2, 3, 4. F4. Just unindent everything. One level. Okay, let's see what that outputs. Ooh. Semicolons, super important. Who knew? Okay. Okay. So I forgot a semicolon there. And there. Struct message, couple static values. Tokenizer does nothing. Oh, class tokenizer probably does need a redefinition, blah, blah, blah. That's fine. Tokenizer set context. Okay, so let's go back to Alright, so this one needs a semicolon. This one needs a semicolon. What else we got going on here? What do they mean? Oh, I put the struct first. Shame on me. Shame on me. How dare I? Struct first. Okay. I should improve a few things. Oops. Can I forward declare the text buffer? Oh, cool. Oh. Yeah, why do we have the word like that? That's terrible. Right line. Oh, it still says I don't have a text buffer. Oh. Okay. I know it has an incomplete. You're supposed to link it. Jeez. We missed a semicolon after class definition. No, that's it. Context. Okay, actually, all right, so Tokenizer. Context. Okay, context. That's the problem right there. Project. This should help a little bit for declaration, blah, blah, blah. Default given for parameter 3. Oh, that's not back on the CPP side. We knew we were going to have to deal with. So project writing is this. This is where we pass those defaults. Yes, it's the in-class initialization of things. But this has to do with the token. So in the project, we have the context, which seems to mostly be working, except for the extern. We have to call it extern. Curious now. It says I know it lives somewhere. Do that. This. Just out of curiosity. Nope. Okay, all right. Fine. We'll just deal with that for now, because the next thing up is tokens. Oh, wait. Oh. These are the pass-through ones. It doesn't like the word buffer because it wasn't defined, because it doesn't know about the text buffer, even if I told it about it. Okay. Fun times. And it doesn't know about text buffers. Delightful. Okay. Token. Yeah, we're gonna need an asset pipeline. These files are getting a little crazy. Not crazy, just making me sad. Making me sad. So we have a context and a token. Okay, maybe project 19. Token. Still these lines. The fun times. Let's see. Token. Operator. Equivalency checks. Leaving that for now. The user needs to know about tokens, context, tokenizer. Nothing else so far. I think these are the things we have to expose in the header file. Rest can remain more or less private, like sealed within the CPP file. I have to go to your way to get those if you want them. Private. Oops, no, come back, stop. Class on video. Let's see, we already have that there. Okay. Writer, give link line, and start this thing. Steal this code. There. If it's the right line, it should be top. These lines don't have to have all the white space because we keep track of that elsewhere. Okay. Same thing here. Top, top, top. There we go, just like that. Where else are we at? Oh. Okay, so that's the end of token, which means over here, get rid of all of this stuff. So like this token, 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 token. Oops, don't do it, don't do it. Dang it. Good. I'll do the work. It's hanging up on me. Big files. Doesn't like big files. On a computer, operating the size of the universe, can't handle big files. Not even that big of a file. I have bigger files that are actually more computationally intensive, or interesting anyway. Okay. Then we're just gonna do this. F3, 1, 2, 3, 4, down, F4. Lastly, where do we write tokenizer or context? All right, let's see what that does. Oh, right. That needs to be scoped. Anyway, probably not the first error. It still doesn't like that. We missed some. Object. Oh. Oh no, not stream reference. Shoot. have to forward declare string reference, and it won't work anyways. Okay, so that's one thing. Oops. Token. All the functions need a semicolon. Okay, buffer. Strref, it does not understand. Right. So what we're gonna do is all of this. I'll give you project writing. Write token. And here, all we need to do is that. Token name is not declared. Okay. I know that. I know that one. I agree. We use the word static here, which never made sense in my mind in CLAN. Buffer, text string. Operator equals. What else? mchar inline. It wants me to capitalize the L. Yes, we might do a offset pipeline. Oh, I know what it's complaining about there. This one. Okay. Project writing. ID token. There, we should have two incomplete types. It makes me sad, but we do have two incomplete types. Now, what we could do. declared classes in namespace. Incomplete type. So, question is, how do I tell it? There is a thing called that. You will link to it later when you get all the data. Here's part of the thing though. Like, I only need, for example, the token constructor can actually be private. Is that true? And token can be a friend of Tokenizer. Try that. Project token public writer top friend Tokenizer. And then we move this bad boy to private. The only person you should be able to construct a token is the Tokenizer. I have to forward declare my Tokenizer as well. Good heavens. There's got to be a way for me to get the declaration allows you to declare pointer to incomplete class. So these have to be pointers. I don't want pointers. Now I have to manage it. Ugh. Okay. All right. Pointers it is. I was afraid that was the answer, but I didn't like it. So ed project where we declare our buffer. Here. That just makes me sad when you can know text pointer there. And underscore buffer equals set buffer. That's fine. That's fine. Let's see here. It's in context. Context. As in context. And it needs a buffer number of messages. Oh, there's nothing to construct. I'll take the empty constructor. Oh, no. Buffer new text buff, which I did not want to do at all, but they are forcing my hand. our shit. Delete underscore buffer. That's sad. If I forward declared, I'm telling you I'm going to define it somewhere. But it just won't believe me. Point to missing terminating sequence. I agree. Okay. Turn the address of our buffer is not currently. Underscore turn m underscore text. No. Ridiculous nonsense. And now token needs to clean up its stupid string reference. We do not want to leak memory. Compilation. Okay, let's just clean and test just to make sure. So VB test parse header now defines for public usage a context, a token, and soon a tokenizer. So those are the forward-facing, outward-facing, worldly things, which means in test.cpp, we will not have to do this anymore, which is good. That's just terrible and an embarrassment. Because the only things we'll touch are these things. Okay. Zero. Like all the extra white space, so there's nothing going on. That's the wrong way. Okay, so that's going to simplify things quite a lot. Project right tokenizer. We'll call that there. Good. Class tokenizer. Public tokenizer. Sure. Semicolon. Delete the things. All done. Next token. Tokenize. That is the end of public. Private. We have context. Oh, char ref. Jeez, McCracken. These are going to cause me the same problems. That needs to be forward declared. Wait, I said friends only here. I don't like friendship in here in my code. Friend. This is not a friend of anybody. Where do we declare this nonsense? Character ref. Don't need that one. Okay, so tokenizer. Blah, 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 blah. End of public private context. This is apparently a pointer. This is apparently a pointer. Those will be incomplete types otherwise. Starting token is a function we're defined in our implementation. Oh, as is new line. Bunch. End of private, and we're done. Therefore, project writing. Okay. So nothing in here is private. I think there are some private functions here. This one, blank, private. No, we namespace it. All right, so this is straightforward. There we go. Set context. Done. Next token. Tokenizer. Get tokens. Start new token. New line. And a bunch. What the? There we go. All right. all of that should be available from test.cpp without causing me too many troubles. Idfdef is most likely not going to work. Just going to live linear. Idfdef. Okay. Undefined reference to themes. Does this make my makefile better? Oh, yeah, that's underscore cur. The tokenizer, when it starts up, right after context, char reference, and the next one is token start char. See. Oh, it actually built. Let's go run it. Error 0. Warning message is 0. Oh. Not that surprising because we're not doing anything with it, but it does work. So if we go to the test parse header file, we're now fully declaring text buffer, character reference, and string reference. Token. Oh, token does need to declare friendship with the tokenizer. The tokenizer, oops. Oh, the tokenizer. All right, let me know what that's about. Top, no. It's VV project. We can't just push these top, 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 top. Top, top. Top, top, top. Okay, VB test parser header file. Okay, context. Looks okay. Token. We have hidden token away. We want to be friends with Tokenizer. Class Tokenizer associated. token blank line. Friend class tokenizer. Okay, so token is a friend of tokenizer, so we can't construct token from anywhere except the tokenizer, because the constructor is now hidden. We're a bunch of jerks. What time is it? It's 5:45? It's almost time for the weekend to get warmed up, so let's see here. Still runs, still builds. So here's what we've done. The test parser. We're exposing to the user the fact that there is a context and these methods to interact with it. That there is a token, you cannot create one. Here are the methods to interact with it. Another line before private. And here's the tokenizer. So you're going to use the context, set the context on the tokenizer, use the tokenizer to get a bunch of tokens one way or another, depending on what we do. That all looks fine. I want an extra line after this private here. So ID string. Writer link. So who was it? Mr. Ed makes. Yeah, that was the one. Source code file rather than an external file. Yeah, so because of Mr. Ed makes suggestion, we're gonna boost our priority a little bit towards asset pipeline next week. It's just the right thing to do, especially since the number of files is proliferated. So we get that out of here. Our code line count goes down. These are treated more like data than anything. Oh, the code structure doesn't matter anymore. So that's just better, I think. It's going to simplify a lot. So let's take a look real quick. Test again. So we're generating 100 lines of code here. Test parser load. Okay, now a couple of utility functions. The text buffer is fully defined here. It's not really exposed outside. Character reference fully generated here. That's fine. String reference also fully defined here. But context is not. That all looks reasonable. Oops. ID to string map. Oh, let's just Let's just cheat. 1, 2, 3, 4. Just for now. We're gonna redo how we do all this anyways. So. Okay, so that'll be better. Token implementation looks. Whoops. Tokenizer implementation. It's not cheap. Let's do it right. There we go. Writer, pop, and okay. That's a joke. DB, test parser, ID, choose string map. Okay, that looks better. Tokenizer implementation. Looks more or less correct. This is, yeah. Okay, so things are coming together. The tokenizer pieces are starting to come together. So back to the old journal. We started generating the tokenizer. Generated a token class. Started generating a tokenizer class. There are too many code snippets to consider. The outward facing classes are now exposed in the namespace in the parser header. Other classes declared and implemented in the implementation. It's here declared header implemented the CPP file. In the CPP file. Pretty core steps. You should consider and prioritize the code snippet pipeline. Thinking about. Okay, I think that's pretty good. So get status and everything. Yes. Commit. Generating token. Started generating tokenizer. Some restructure. Okay. Okay, I think we're gonna start wrapping it up there. So thanks for dropping in. Always appreciate your chat. Appreciate your company. We are going to keep on generating code next week. Actually, no, we're gonna do the asset pipeline. I think it's gonna make for cleaner, easier to read code. And then, and we won't have to count the generating code towards our line count. So we should actually see a huge shrink in code next week. So thanks for dropping in. Thanks for your attention. Next Monday, we'll back into game development, Monday through Thursday, compiler development on Friday. Feel free to ask questions and show me your projects. And yeah, have a wonderful weekend. We'll see you next week.